Hi guys, so today we'll be solving this problem from Leetcode number 33, search in rotated sorted array. There is an integer nums array nums sorted in ascending order with distinct value. Prior to being passed to your function nums, is possibly rotated at a known pivot index x, such that the resulting array is this 0 index. For example, this array might be rotated at pivoted index 3 and become this array. Given the array nums after the possible rotation and an integer target, return the index of target if it is in nums or -1 if it is not in nums. You must write an algorithm with O log of n runtime complexity. So here our input is nums of array and our given input, another given input is target value. Okay, so our output, it says we need to find the index of the target value if it is in the nums array. If not, then return -1, right? So for this one, our constraint would be, it says you must write an algorithm with O log n, right? So our constraint is must be run time of O log n, right? So our edge case could be that, let's say our nums only has one value, and if that value is not target, then we can just return -1, right? Okay, so let's take care of our edge case first. We can just say if nums.length equals to 1 and nums at 0 is not equal to target, then we can just return -1. So for this one, at first glance you might think of basically just iterating through the array and finding the target value here, which is 0, and just returning the index of that target value. So in this case it will be 4 because the 0 is at index 4, right? 0, 1, 2, 3, 4. And then if you look at the next example, 3 does not exist here, so they are returning -1, right? But if we were to look through each element in the array, then we would not be running on O log n. It will actually be a linear, so it will be O of n. It's because we're checking every single value in the array. So since our constraint is that we need to make sure the runtime is 0 log n, we would have to use the binary search method to find our target. So the way that binary search method works is that we would either check the target if it is on the left side or right side, and we only pick one side to search in, and we would keep doing that until we get the target value, or if not, we'll return -1, right? So in the binary search method, the array becomes smaller and smaller because we are cutting the array into subarray and another array until we find the target, right? So if we use the binary search, we effectively cut down on our sort time because we're not looking at every single one of the element. So in this case, we can think about two different possibilities for our arrays. So let's say that we were given a sorted array, then it was rotated multiple times, and it went back to the way it was. So let's say we're given an array that was already sorted, right? So if we rotate the sorted array enough time, eventually it will land on the way it was before, right? So we need to find a way to solve this problem and find the solution using this case. And the other way would be that it's not sorted, right? So it could be like 1, 8, let's say 7, and then on the other side we could have 0, 1, 2, 3, right? So let's come up with a logic to solve this way first, so that the array is already sorted, right? So the way we could check if our array is already sorted is by checking if our middle is bigger than our left, right? So if the middle is bigger, then we know that is sorted. So let's say we'll assign left to 1, right to 5, and put this as a middle, right? So if we know that middle value is greater than left value, then we know it's sorted. But even in this case, we need to check either left side or right side. So what we can do is ask if the target is less than equal to num value at middle value, and target is bigger than equal to left value, right? So if this is the case, then what we need to do is reassign the right side. So we would reassign the R to index 1, because now we need to only check this side and not that side. So the reason we're not counting the middle when we search is that if we know that the middle number is our target, then we can just return m, right? We don't have to go through this entire process to find the target value. So since we already know that middle is not the answer, then we would either go left or right. Okay, so in this case, we would have to assign right to middle minus 1, right? Because we are going backward 1 step. But if it's the case that the target is not in this side, then we would have to look at that side. That means our left, we have to change it to the element after middle. So that would be left equals to middle plus 1. So now we have to think about a case where, let's try to, okay, now we have to figure out about the case if middle value is smaller than left value, right? So if the middle is smaller, like in here, the middle is smaller than the left, then we have to do something else. So at first we will check the right side. Let's say we check the right side, right? And let's say we couldn't, so we'll check the target value on the, let's say we check it on the, okay, let me think. So let's say we are checking on our left side, right? So we'll check by reassigning the left and right again. and let's say our middle is 0 here. Okay, let's check our left side first. And if our left side does not have our value, then we would have to check the right side, or if we have the right, if we check the right side and if this doesn't have the value, then we'll check the left side, right? So let's check the right side first. So we would say if target is bigger than equal to middle and target is less than equal to right. So in this case, what we have to do is assign the left to middle plus 1. Right? And then after that, we have to check if it's not in this side, then we will have to check the other side. So the other side we would be else. We would say we'll move the right to here. All right, so else right equals to middle minus 1. So that's how we would solve this problem. So let's try to code this one out. Okay. So I'm going to comment this out. Okay, so first, let's assign our let left equals to 0, let right equals to, so we said it will be end index, so it will be nums dot length minus 1. So we will have to use a while loop in this condition. It's because we want to keep reassigning the left or the right value until we find the target, right? So in order for us to do that, we have to check if, so we would have to go through this loop until left, while left is smaller or equal to right. Because if the left index is greater than right, that means we have already gone through all the elements. And at that point, if we still didn't find the target, we just have to return -1. So at first, we need to find the middle index, right? So the middle index is basically the average of left and right index. And I would have to do mat.floor since I need mat.floor because I need a value without the decimal number. Because if we took the average of the array and if it is even, then we would get decimal. That's why we are using mat.floor to ensure that our number is solid number without any decimal. So let's take care of this case first, right? So if we do if nums at middle is bigger than nums at left, then we know it's sorted, and we will check if you want to look at left or the right side. So I'm going to say if target is, it has to be smaller than equal to middle and less than equal to left. So if the target is smaller than equals to nums at middle, and target is greater than equals to nums at left, then we have to do something. Okay, then what we do is, in this case, we reassign the right to m minus 1. So that would be right equals to middle minus 1. The reason we're doing minus 1 is because we want to go back a step. Else we know that the target is not on our left side, so we need to look for on our right side. That means we need to reassign the index at left. So left would be actually middle plus 1 because we're going forward one step. So now that we have taken care of this, now we have to take care of the situation where the array is not completely sorted, right? So since this one was initially a sorted array and rotated multiple times to get this result, we know that either one of the side would be sorted. So now let's do the else statement for this case. So we said we will check the right side first and see if the value is there. So in that case, it will be if target is, so we're checking, okay, smaller than equals to nums at middle, and target is greater than target is. So we need to check smaller. So it'll actually be other way around. So if the target is greater than nums at middle and less than nums at right, okay, so we said if the target is greater than middle and target is less than nums at right, then what we need to do is reassign left to middle plus 1, right? Because we want to switch the left to be here. So we just compare these values. But if that's not the case, what we have to do is assign the right to middle minus 1. So if we go through this while loop and we still haven't found our answer yet, then we would return -1. So I just realized I missed one key point. So I did say earlier that if we know that the middle is the answer, then it's best if we just return that already, because we don't want to go through this entire process and just realize that the middle was the answer, right? So in that case, we would just say if target equals to nums middle, then we'll just return middle. Okay, so yeah, so it's always good to write out what you're thinking and check what works and write it down, because I had already come up with this logic, and how, like, when I was coding for else, I kind of got confused. But when I looked at what I had wrote before, then it made sense for me to switch the greater than equal to sign around. But yeah, so it's always good to write out the code first and then start coding. Anyhow, let's try to run this code and see if we pass. Okay, so we at least passed for this test case. Let's try to submit and see if it actually works. Why is it not working? Alright, let me quickly check what I did wrong. Must have missed something. Middle is greater than equal to left. So we want to make sure that, you know, if there's only one element, then, you know, left and the middle will be the same. So we want to make sure that we do include equals to middle. Okay, let's try to run it again and see what we get. Okay. So it works. Yeah, it's a bit, you know, confusing, but if you were to write down your code and see what works, and we can just compare the steps we took to get to the answer and then code, then, you know, it will be a lot less confusing. So I hope that helped, and I'll see you guys in the next video.